I'm Emily Elias. I'm the Acting Director of the Southwest ClimateHub. Also speaking today will be Katie Steele. She's our coordinator, and Julian Reyes, our fellow. So as I said, I am the Acting Director of the Southwest ClimateHub. This is one of 10 climate hubs across the nation. So you are at one of our 10 locations. We were formed in February of 2014. So we are approaching our 5-year mark. We're approaching our 5-year review. This is an interesting organization, the Climate Hubs. We really grew up within USDA. We are a USDA organization. But we're basically what they're calling one USDA, in that many different parts of USDA interface within the Climate Hub network. And you'll notice on this map, these are the locations of the 10 hubs across the country. 5 of the stars are red, and those represent the climate hubs that are at ARS research locations. The other 5 stars are blue, and those represent the climate hubs that are at Forest Service. So we were established, as I said, about 5 years ago. The mission of the climate hubs is really to develop and deliver science-based, region-specific information and technologies for agricultural and natural resource land managers, and I also think importantly, communities. So we're not just talking about land managers, but the communities that are impacted by the changes that we anticipate in weather and climate in the future. And we hope that that information will then enable climate-informed decision-making and provide assistance then to implement those decisions. So the hubs then really work at this interface between science, knowing the research, being at the ARS, and services, delivery of that information, which traditionally is really a cooperative extension function, right? Extension has been around for about 100 years, maybe a little longer, and really work directly with producers. So often we operate at that level where we're sort of training the trainers. So we often work with extension educators and teach them about weather and climate. We work with NRCS and try to talk to them about what producers need and then develop that. We now operate in 3 big overarching functional areas. That is really research, we still do research, science translation, and information synthesis. So those really core products, making sure that we have the most recent research information and that is provided. We also develop tools and technology transfer. So I'm going to give you 3 examples, and then I'm going to stop talking about all the great things that the hubs have done, and we're going to talk about some real climate data, and Katie will take over there. The first thing that the hubs did as a network, however, was pull together some vulnerability assessments. This was actually a pretty big endeavor, because we were looking at the vulnerability of rangelands, croplands, forest lands across all of our regions, and publishing that. When we put ours together, at one point it was around 430 pages long. It was a huge document that then needed to be winnowed down into something that people would actually read and use. It became about 50 pages. It's much more useful in that format. But we did take that information and publish a special issue in the Journal of Climatic Change. So that information is still out there, and there's an article on rangelands, written by the lead author was Chris Hastad on that article. There's an article on forest lands, specialty crops, field crops, climate data. We put together a data set with projected mid-century temperature and precipitation changes along with those ranges, so that it's really accessible. People can look at that and say, okay, on average, this is what the best science out there says it might be in the future. So that is now published. All of the articles are open access, freely available, and it's online. We had a lot of partners working with us on that as well. So all the hubs, land-grant universities, and USDA agencies. Another thing that we did that actually had a lot of additional benefits is something that Katie worked on. And these are drought workshops that we were doing. This is actually at the Jornada Experimental Range. You were in this room this morning. This is in our outreach and educational functional area. We worked with the National Drought Mitigation Center and the hubs. We were able to get stakeholder feedback, which was really great because what we learned was the stakeholders need more precipitation information. And Katie was then able to work with the Farm Services Agency and the Cocoa Rods Network to ultimately install 186 new gauges across New Mexico in fiscal year 17. And that matters because those gauges then feed back into the drought monitor, which then impacts some of the programs. The last thing I'll mention is GrassCast. This is out of the Northern Plains ClimateHub. This is a project that really uses precipitation information along with previous relationships, NDVI, ET, to then project what the forage will likely be that year. And so, as you can imagine, it gets better throughout the year. It's maybe not so good in May. It gets better in April or May as you go throughout the year. And this is expanding into the Southwest region. We've been evaluating those relationships before we create the tool because we want to make sure that it is really accurate, since decisions may be based on this tool.
So good afternoon, everybody. I'm going to talk to you today just a little bit about the available data, giving us a picture of the history of climate in our area and what it might look like in the future. So when we're looking at climate data, we really need to put it into the context of what's happened in the past. And the most accessible data is actually from the NOAA's Cooperative Observer Network. This is available for most areas in the country from about 1895 onwards. And to get these charts, I actually went to Climate at a Glance, which is a tool supplied by NOAA. And it gives you various options for plotting the data, but this is time series data. And this particular data set is from Doñana County, where we're located. So if we look at how temperature has changed over the last 120 years or so, you can see in the early 20th century, there's not much of a trend going on until we get to the mid-century and then a slight peak in the 1950s. But then from the 1970s onward, a strong trend in rising temperatures. And if we try and fit a line to the whole lot, there seems to be a fairly significant trend in rising temperatures in Doñana County. And this reflects what's going on at a global level if you take the global average. It's not happening everywhere. We can discuss that on the side a bit later if anyone's interested. Look at June temperatures. It's been a rotten June. I don't know about you, but I've been really, really hot this June. I'm like, it can't have ever been this hot. Well, it was hotter in 2013. But again, we're seeing this trend in rising temperatures. Looking at the y-axis, actually, it looks like it's rather exaggerated. So do pay attention to that. It's only a few degrees. That few degrees can make an impact, especially if you're looking at a night not cooling down and not giving your vegetation that relief. Precipitation, historical precipitation, very variable. Is this trend significant? I couldn't tell you if this rising trend is significant for Doñana. But the story about precipitation is it's really hard to model any kind of historical or even future precipitation because it is so variable. And a lot of this variability is driven by variability in the monsoon as well. So I showed you, these are just time series graphs here where you're looking at about 1890 to 2018, 2017. And it's just showing you the absolute change in temperature over time. But we can see changes a little easier if we plot the anomalies. So an anomaly chart is where you take a period of time, say 1981 to 2010, and you take the average value of, say, temperature or precipitation for that 30-year period. And then you look at every individual year over a longer period of time and you see how it varies from that average. So I chose 1981 to 2010 because that's what a lot of the climate models look at. That's what they call a baseline period. So looking at the difference from the 1981 to 2010 average, we see up to about the early, or the late 70s, 1980s, most of the last century was colder than our most recent 30-year period. Late 90s into the 20-teens, definitely warmer. So we can clearly see that change over the last century there. Precipitation, as I mentioned before, not quite so easy to spot trends, but in this graph here we can clearly see the 1950s drought period, dry occasions during the early part of the 20th century and during the 1930s. So when we talk about future climate change, and we use a lot of these data sets within the ClimateHub, we want to know what biophysical changes are going to happen in the future. So we turn to those people doing global climate models, or running global climate models, to provide us with those projections of what's going to happen with temperature and precipitation in the future. And if you're not familiar with the global climate model, in a nutshell, what it is like a big net over the globe, with lots and lots of different layers. So imagine pixels in a sphere around the globe and then multiple layers, and each cell is modeling maybe part of the atmosphere, the land surface, the ocean, and each cell is being represented by multiple equations, and they do process billions of equations. They're very, very data-hungry models. But what you get out of it at the end is a projection of future climate variables. So in a very basic sense, some of the outputs we get from global climate models would be, say, mean annual temperature or precipitation in a year. And the graph on the left here shows historical and future climate. So we use global climate models to model historical data, so we know how well they're doing, and that gives us an idea of how well they'll function in predicting future data. Now in these graphs here, both of them show solid lines surrounded by shaded lines. The solid line gives you a multi-model mean. There are over 60 models run by over 20 climate modeling groups. So we do get some variation in the results. And we also get some variation because we use different scenarios of how greenhouse gases and their concentrations in the atmosphere will change in the future. So on the left here with temperature, even under lower concentrations of greenhouse gases, we still see rising temperatures throughout the 21st century. And under higher concentrations, which unfortunately we seem to be on that path right now, we see much higher estimates of annual average temperature. Once again, precipitation isn't showing quite such a clear trend. But we do expect that in the southwest, drier areas are going to become drier. We expect precipitation is going to decrease, especially in the spring. But that being said, the precipitation that does fall, more of it will be falling in extreme events. Variability will continue. We'll still see this interannual variability. Some scientists with plenty of evidence are predicting mega droughts of 35 plus years in length. Arguably, we're in a mega drought right now. Some findings indicate that the monsoon is going to start later. We're going to see more of that precipitation falling in the later monsoon as opposed to the earlier monsoon. And there's going to be multiple impacts on rangeland. And here, I'll just focus on the stress in all systems. And I could get into the doom and gloom of ecological drought, degraded soil, but what the Jornada Experimental Range is doing is working towards building resilience within rangelands and creating those solutions for mitigating climate change impacts on rangelands. And some of that work is also being done by Julian, not necessarily on rangelands, but looking at risk management and how we look at risk now in the present and how that may be translated to future solutions.
I'm Julian Reyes, and I'm the fellow with the USDA Southwest Climate Hub. I'd like to introduce myself as an engineer who likes to talk to people. That's my background, so that's why I'm all about the data, but what can we learn from the data? And so as part of the USDA Climate Hub program, we're able to integrate a lot of interesting data sources across USDA, the one USDA, and so we're working with the Risk Management Agency, who's actually in charge of the federal crop insurance program, and that is an important safety net for our farmers and ranchers in terms of managing their crops in a changing climate or in terms of price decline. So similar to your auto insurance. And so part of that motivation is in terms when there's extreme weather events and long-term changes in climate and how they impact the ag production and food security. In 2016 alone, the value of crops that were insured is actually $100 billion. That's a lot of money. It's not a chunk. And it also may increase the fiscal exposure of the federal government in terms of if we see more extreme weather events and long-term changes in climate, the federal government is on the hook for that in terms of the crop insurance program. So that's a very important thing. So our guiding question for our project is what can crop insurance data tell us about weather and climate impacts on agriculture? The image on the left shows a U.S. drought monitor in 2012 during the height of the drought in the Midwest. And here you have the crop indemnities, also known as payments to farmers. You can see the dark red shows where the majority of the payments were made out, similar to what you see in the drought monitor. And so we're trying to see what links are there between the two. And so I would like to go through this crop insurance 101 diagram, but I don't have time. But basically, you can read what's going on. But essentially, farmers will pay a certain premium to private insurance companies, and the federal government will subsidize their premium. And the federal government will also underwrite any gains or losses. That's the bottom line. But the program is very important to our farmers and ranchers, nonetheless. And so any of these losses, we call them causes of loss, or what we call COL. So a cause of loss could be a price decline due to a trade war maybe, or it can be a natural cause of loss, such as drought or hail. And so between 2001 and 2016, about $100 billion were actually paid out to farmers. This was after a disaster. And out of those $100 billion, we can partition out due to what reason. And we see that most of that, almost above 40%, is due to drought in the orange. The next highest cause of loss is excess moisture or precipitation in the dark purple, followed by hail, heat, and freeze. That's the top 5 causes of loss. And you can see the other top 5 there, or in the top 10. And we can also look at the top 10 crops that report a loss. And so it's not surprising that corn, wheat, soybeans, cotton, and grain are the top 5 crops that have received a loss. We can look at those causes of loss also over time, and the dotted lines represent when the Farm Bill was passed. And you can see at the height of the drought in 2012, you can see a huge spike in reported indemnities or payments to farmers, and a large portion of that, actually most of it, is due to drought. And what we can do with the data is we can also look at it spatially by county. Here we have the top county cause of loss from 2001 to 2016. We can also look at it by particular years. In 2012, you can see it's all orange, but then in 2015, it's mostly purple. So you can see the impacts of weather and climate in these data. So for the Southwest climate, here's our 4-state region: Nevada, Utah, Arizona, New Mexico, sometimes California. And what we can do is we can look at the top causes of loss by county, but also by state. So you can see in these pie charts, the failure in irrigation supply with the green color is the top cause of loss in Arizona and Nevada, while the top cause of loss is drought in Utah and New Mexico. And that is also due to what commodities or crops are grown in those areas, leading to you can look at the top causes of loss by those commodities in the region. And so you can see, for example, wheat, the top cause of loss is drought, while for cotton, not surprisingly, it's failure in irrigation supply. And then, of course, California comes in, and California is always different. And so if we were to look at California, the top cause of loss for California is heat. But if you look at the top crops, cotton is one, but also it's mostly nuts and fruits. And so you can see almonds, and then you see cherries, grapes, pistachios, and prunes. And you can see the composition of the top causes of loss is quite different than if we just took the 4-state region minus California. And so what can we do with these data? Well, we can provide them in a way that anyone can not necessarily make these figures, but discover these data and do some sort of analysis. And so we created the Ag Risk Bureau with the help of Jeb Williamson. It's an interactive data viewer, on-the-fly analysis, where you can essentially choose your spatial unit, whether it's by state, by county. So you can click on any county right there. You can choose your temporal resolution. You want data at the monthly or annual scale, and you can look at whether you want causes of loss or your different crops. And so I would do a live tour, but the internet's kind of sketchy. But here's what the landing page looks like. And so you would see this map, and so you can essentially look at nationwide data by not clicking on anything, or you can click on any individual county, and it'll produce that data set for you. So you can get a time series of your indemnities over time, such as this time series figure. You can get the aggregate cause of loss, and so over the whole nation we see drought, excess moisture, hail, like I described, are the top causes of loss. And so here's just another a zoomed-in version of that over the whole nation. You can see corn, wheat, soybeans, cotton are the top commodities receiving a loss. You can see the top losses by cause of loss. And then lastly, as a quiz, does anyone know which commodity I'm choosing here in terms of which counties these represent in terms of what what crop is grown here that has received the loss?
Pecan.
Yes, good job.
Way more than
That's
that.
my favorite example. Yeah, those are pecans. So for example, I was able to pick out pecans in the Ag Risk Viewer, and we can look at the top causes of loss for pecans. So we can see across the pecan belt, if you want to call it that, freeze, excess moisture, heat, and drought were the top 4 causes of loss. You can see it over time and also by month. And then you could also click out just Doñana County if you want, or just the Southwest, but you can do a lot with the Ag Risk Viewer. And I think that's everything. And on our handout, we have the website to our website, the Ag Risk Viewer, and a lot of other tools. And I think Katie has a climate change and
Yes,
variability worksheet. So thank you.
Just a